For part C, partially polarized light is shown through a polarizer and rotated 360 degrees. The maximum intensity of this would be where the parts of the light that are already polarized are in alignment with the polarizer so that all of the polarized light goes through. And the minimum of this would be where all of the polarized light is negated. So this is all polarized and none. So for this one, for none of the polarized light making through, this would be half of the unpolarized light equaling the intensity. And it would be plus 0, which would be the amount of polarized light that made it through for a minimum. For the maximum, it would be half of the unpolarized light as well as all of the polarized light. However, this is 7 times this, so that would be half of IU times 7 equals half of IU plus IP. So this is 3.5 IU equals 0.5 IU plus IP minus 0.5 IU on each side. Thus you have 3 intensity unpolarized light equals intensity polarized, meaning that 3/4 of the light is polarized and 1/4 of the light is unpolarized, meaning that the answer is 3/4. Now for D, it says that a person is sitting behind a glass wall and they can't see because of a glare of reflection, and light that is reflected is polarized. So a polarizer can be used where at the correct angle it will negate 100% of the polarized light, meaning that the glass once again becomes see-through. It can do this because the polarized light is coming from a single source, meaning that at a single angle it will negate all of the glare and not just parts of the glare. So that is how a polarizer can be used to make it easier to see the person on the other side of the glass wall. On to part 2. So part 2 all pertains to the 2-slit experiment. So for A, it asks to explain why light is able to reach the middle of the screen. And this is because when going through the slit, the light expands outward, and it does so at each slit. And so, because light waves interact with and interfere with one another, on the screen, this will show up as bright spots wherever they interact constructively or interfere constructively, and dark spots wherever they interfere destructively. So the point that is on the screen that is equidistant from each of the slits, which is what M is on the diagram, the middle of the screen will have a bright spot because they interfere constructively. So part B says that one of the slits is covered and explains the intensity of the light at M. So say you cover up the bottom slit, nothing here. So light has a strange property where it will also interfere with itself if it is not interfering, or it will interfere with itself And so it will create a pattern similar to double slit. So the point M, because it is in between the two slits, will likely be a dark spot in between constructive interference of the single slit. For part C, it says, state the feature of the graph that shows that the slit width is not negligibly small. And so, as the slit